So where we stopped? So where we stopped? So we have discussed about halides. So there are two types of halides that will form. One is going to be trihalides, another one is going to be pentahalides. Is it clear? Trihalides and pentahalides. Is it clear? So nitrogen will exist as a trihalides, whereas it's the group 15 members other than nitrogen. It will exist pentahalides. And halides are important in a PCl5. PCl, the geometry is going to be trigonal bipyramidal, hybridization is going to be sp3. Is it clear? So in a PCl5, the bond lengths, all the bond lengths is not equal to E, not is going to be same. We have two different bond lengths. One is going to be axial and equatorial. Axial bond length is going to be more when compared to equatorial. Is it clear? Suppose if we heat the PCl5, it will dissociate into PCl3 plus Cl2. Is it clear? Another important point, okay, regarding PCl5. Okay, so in the case of PCl5, okay, in solid state, in solid state, that will exist as an ionic form. In a form, ionic form. Is it clear? For example, PCl5. So this will exist as an ionic form. PCl plus 4 plus PCl 6 minus. In solid state, it will exist in an ionic form. Ionic now you have a positive and negative. Is it clear? In the case of this one, ionic formula, positive and negative species exist in solid state. Whereas in gaseous state, ionic form. Whereas in gaseous state, it's going to have a covalent nature. Any nature? Covalent. Whereas in solid state, it has a ionic nature because one positive and one negative. Is it clear? So what is the hybridization of this one? What is the hybridization of this one? sp3. sp3. What about this one? sp3. Please note this. sp3. Solid state will exist on ionic form. In solid state, it will exist as an ionic form. Is it clear? Next, most important. Hydrolysis of ECl3 halides. Hydrolysis of ECl3 halides. For example, you take NCl3. Okay. Hydrolysis means you treat with water. Okay. It gives ammonia plus you have HOCl. HOCl, that is hypochlorous acid. If you analyze in NCl3, you will get hypochlorous acid. Hypochlorous acid. Is it clear? Similarly, you take PCl3. Okay, PCl3 is to treat with water. So in this case, you can easily remember this reaction. You will like PCl3, water molecule, H, OH, OH. Okay, you can cut off HCl. So what do you get? You will get H3PO3 plus 3HCl. Please note this point. Now you can easily understand this is going to be only for this case, it's going to be plus 3. This also plus 3. This also is going to be plus 3. The second example is going to be arsenic halide. Arsenic chloride, if you do hydrolysis, this also exists. Arsenic oxide plus 6 HCl. The last example, antimony trichlorides, hydrolysis. So this will exist as a SOBCl plus 2 HCl. The last one is going to be bismuth trichloride H2O, that gives BiOCl plus 2 HCl. Okay, so please note this. This is the hydrolysis of. Hydrolysis means reaction with water. Is it clear? Reaction with water. Next example. Reactivity towards metal. Reactivity towards metal. Okay. Reactivity towards metal. Is it clear? For example, so group 15 elements. Okay, group 15 elements reacts with metal and form binary compounds. Group 15 elements react with metals and to form binary compound having -3 oxidation state. For example, okay. For example, suppose you treat with calcium. Okay, listen. Calcium plus nitrogen. In a metal, general form it will form a compound. The compound is going to be binary compound, where the oxidation state is going to be oxidation state of group 15 element is going to be -3 oxidation state. In oxidation state -3. For example, we have what is this? This is going to be calcium. So what you will get? You will get a. This is going to be this. You take a reactivity towards metal. So in this case, you give it a formula. So calcium in this case is going to be nitrogen. So what is the valency in this case? Is going to be 2. What about the valency of nitrogen? Is going to be 3. We just crisscross. Okay, minus. This is the case. Now minus this oxidation state N3 minus. Now N3 minus you can call this as a nitrite. Calcium nitrite. Okay, where calcium is going to be plus 2 oxidation state, nitrogen is going to be -3 oxidation state. -3 oxidation state. Is it clear? Similarly, other compounds also. For example, suppose you treat with calcium with phosphorus. Okay, so this is going to be. Okay, so what you will get? You will get calcium 3P2. And we have other compounds also. Sodium, and we have a zinc 2. So these are the compounds where it is going to have a -3 oxidation state. Similarly, you can write sodium plus arsenic, zinc plus tin, and magnesium plus bismuth. Okay, so metals, metal react ஆச்சுனா என்ன oxidation state exhibit பண்ணனும் கேட்டா -3. இதை எப்படி ஸ்ப்ளிட் பண்ணுவேன்? CaP, correct? Ca is going to be 2, always plus 2 oxidation state. Phosphorus is going to be 3. In this case, Na always is going to be plus 1 oxidation state. Arsenic is going to be 3, crisscross பண்ணா Na3, arsenic 1. What about this one? Zinc always is going to be plus 2 oxidation state. This is going to be 3, crisscross பண்ணா. Next, magnesium always is going to be plus 2. Bismuth group 15. Okay, but in this case it's going to be 3. In this case it's going to be 2. So these are called ionic compounds. Is that clear? So don't remember this one. Everyone will tell you. Okay. So So you have to place the valency, corresponding valency, then you have to go for the crisscross. Okay. So that's all about the group 15 elements, the properties, physical and chemical properties. Is it clear? So these are chemical properties and physical properties we have discussed. Is it clear? Yes or no? The compounds of group 15 line up in nitrogen or preparations that you have to read. Okay, nitrogen, ammonia. These are important compounds that is there in HSC. In other words, compounds of nitrogen. Important compound N2. N2 or preparation. Other properties that you have to read. Similarly, ammonia preparation, other properties. Is it clear? Next, compounds of phosphorus. Compounds of phosphorus is very important. Halides and oxoacids. This the deleted portions. In a portion, deleted portion, but HSC related. So please read that. Is it clear? Yes. So next we are going to discuss about group 16. Okay, group 16. Group 16 elements. Is it clear? Group 16. Group 16 elements. Group 16 elements. Group 16 elements. So what are the elements that is present in the group 15, 16? Oxygen. The family. Group 16 kilogram. Chalcogens. Okay, chalcogen meaning more forming elements. Chalcogens meaning more forming. Chalcogens meaning more forming. Is it clear? Okay, so mostly ores are available. In the form available either oxide ore or sulfide ores. You know oxide. That's why it's called chalcogen. Chalcogen is the meaning ore forming. So what are the elements that is present in group 16? Oxygen, sulfur, selenium, tellurium, and polonium. Okay, oxygen, sulfur, selenium, tellurium, and polonium. Is it clear? So general electronic configuration. General electronic configuration of group 16 is going to be NS2, NP4. Is it clear? You will have 2S2, 2P4. This is going to be 3S2, 3P4. Okay, this is going to be 4S2, 4P4. Inge D irukra just you remember. This is going to be 5S2, 5P4. This is going to be 6S2, 6P4. So atomic number is going to be 8. So here 16, 8 add 24, 18 add 24, you will have the 18 add 24, in this case is going to be 32, the magic number. So atomic number in this case, what is the atomic number? 34, in this case 34 plus 18, 56. 56 plus 32. 80? 80. 80. Is it clear? Yes or no? In this case, polonium is going to be the, listen carefully, it's a radioactive element. It's a radioactive element. It's a radioactive element. 52. 52. 84. Sorry. Is it clear? Among this one, which polonium is going to be in nature? Radioactive nature. Your half-life T of your half-life is going to be 13.8 days. Your T of 13.8 days. Is it clear? Yes or no? Among this one, these two are oxygen and sulfurs are non-metal. 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 Is it clear? Non-metal. Whereas selenium and tellurium are metalloids. Metalloids. Now, what about this one? Polonium is going to be a metal, but it is actually radioactive element. The properties are discussed from what is it clear? Elgo is going to be a radioactive metal. Next your it's a radioactive metal. Next occurrence, you read this. Occurrence. Already I discussed most abundant element in the earth crust here. Most abundant element. Oxygen. Oxygen is going to be the first, followed by silicon, then aluminum. Sorry. Okay, most abundant element on the earth crust is going to be oxygen. Now the percentage it is going to be 46.6% by mass percentage on earth crust. Earth crust level, is it clear? So these are the occurrence. Next is sulfur. Okay, sulfur. Is it clear? Your percentage on earth crust is going to be 0.03, 0.1%. Your abundance is going to be very less. Okay, earth crust level abundance. Is it clear? Any doubt on this? Okay, next, mainly sulfur exists in terms of sulfide. Sulfur earth crust in terms of sulfates. Sulfur mainly exists as a sulfates. For example, next, barite. Okay, barite. Barium sulfate. Next, and as well as it can also exist in sulfide form. Sulfur also can exist as a sulfide in earth crust. Example, galena. Formula is going to be lead sulfide. Next, zinc blende. Zinc blende. Formula is going to be Z10S. Okay. The next one is going to be copper pyrites. Okay, copper. Copper pyrites inor pair. Can you tell me the name? Copper pyrites inor pair. Metallurgy le padise bhaiya. Copper pyrites are called fool's gold. Okay, fool's gold. Okay. Fool's gold. Is it clear? Yen conundrum. Yen are fool's gold. Is it clear? Okay. So these are the few things regarding occurrence. So for sulfur mainly exists on the earth crust either in sulfate form or in sulfide form. Sulfide, galena lead sulfide, zinc lead, and copper pyrites. Is it clear? Next we are going to discuss about atomic properties. Now we are going to give the answer for this. Atomic properties. Okay. First atomic property we are going to discuss about atomic radii and ionic radius. Atomic and ionic radius. Atomic and ionic radius. So nothing special in this. Left to right pona. Atomic radius decreases. Down the group pona. Increases. Is it clear? Very good. So atomic radius or atomic size. Okay, if you move from left to right. Okay, left to right pona. Okay, left to right. If you move from left to right, atomic radius decreases. Whereas top to bottom, along the group, atomic radius increases. Left to right pona, atomic radius decreases. Top to bottom of the atomic radius is going to be increases. Is it clear? And either exception என்ன அப்படினா, listen carefully. Note this point. Note. Okay, அப்ப எது smaller in size ன்னு கேட்டா what is group 6 ல எது smaller in size? Oxygen. Is it clear? Go. Oxygen, the size of oxygen is going to be exceptionally small. Is given in the NCERT. Exceptionally small. The size of oxygen atom is exceptionally small. Okay, exceptionally small. Is it clear? The second property is going to be oxygen size is going to be very small. Okay, small size. The size of oxygen atom is going to be very small. Next, ionization enthalpy. Second property, atomic properties. Second property is going to be ionization enthalpy. Nothing special about this one. Ionization enthalpy. So ionization enthalpy you have to give based on the electronic configuration. Electronic configuration. Already we have discussed left to right pona. Ionization energy inversely proportional to atomic radius or atomic size. Is it clear? Ionization energy left to right pona appadina, ionization energy increases. Top to bottom ana ionization energy decreases. This is general trend. Left to right pona ionization energy increases. Top to bottom ana ionization energy decreases. Is it clear? Now, suppose we compare group 15 and group 16. This already I have discussed. Group 15 and group 16. That means NS2, NT3, NS2, NT4. This is ionization energy adhigam. 15 or 16 or 16 or NS2, NP3, NS2, NP4. This ionization energy is going to be more. 15 is going to be more when compared to 16 because in here off-field configuration. In a configuration, release ko. So when compared to group 15 and group 16, ionization energy adhigam. Group 15 has a more ionization energy. The elements of group 15 have more ionization energy when compared to elements that is present in the group 16 because off-field. Is it clear? Next important property is going to be this second. Next is going to be electron gain enthalpy. That is the most important thing. Electron gain enthalpy. Electron gain enthalpy. Electron. What is the meaning of electron gain enthalpy? Energy releases when you add electron to an isolated gaseous atom. To an isolated add பண்ணும்போது now energy change இருக்கும். Energy change. Is it clear? Yes or no? Particularly in the case of group 16. Group 16 has all the elements in the group 16 has negative electron gain enthalpy. All group 16 elements means
all elements that is present in group 16 has a negative electron gain enthalpy. What is the meaning of negative electron gain enthalpy? Huh? So what is the meaning of electron gain enthalpy? That is particularly negative electron gain enthalpy meaning. Exothermic meaning. What is the meaning of it? Huh? Energy release, vapor energy release of electron add பண்றது electron அப்பனா electron affinity அதிகமா இருக்கா கம்மியா இருக்கா அதிகமா. What is the meaning? Electron affinity less or more if you have a negative sign. Negative sign இருந்தா more or less. Electron gain enthalpy negative na what is the meaning of it? Affinity அதிகமா கம்மியா? Affinity is more. Affinity is more. Is it clear? Affinity is electron gain enthalpy positive na meaning என்ன? Affinity is less. Affinity is less. புரியுதா? அப்போ all group 16 elements के electron affinity அதிகமா கம்மியா கேட்டா less or more கேட்டா what is the answer? More. Is it clear? அப்போ electron கொடுத்தா வாங்கி வச்சுக்கோ. புரியுதா? electron இருந்தா என்ன பண்ணனும்? வாங்கி வச்சேனா மாறும். Corresponding anion மாறும். Corresponding என்ன மாறும்? அப்போ anion form ஆற tendency அதிகம். Anion form ஆற tendency is going to be more. Is it clear? அப்போ among this one, what is the order? அப்போ இதுக்குள்ள எனக்கு negative electron gain enthalpy இருக்கும். Please note this. Look at the periodic properties. நடக்குது. Is it clear? Order கேட்டானா what is the order? What is the order? What is the order? Electron gain enthalpy order. Oxygen. What is the answer? Okay, so it's very clear. Selenium, sulfur, selenium, tellurium, polonium. This is the order. Please note this. So electron gain enthalpy order is going to be more. This is very important in terms of sulfur and oxygen. Which one has the more electron gain enthalpy? Sulfur. Why? Why? Which has more electron gain enthalpy? Sulfur or oxygen? Answer is very sulfur. Why oxygen has more electron gain enthalpy? Negative electron gain enthalpy. Negative na attraction is going to be more. Electron கொடுத்தா ஈஸியா வாங்கி வச்சுக்கோம். அப்ப sulfur versus oxygen. Because sulfur size, sulfur and oxygen is extremely small size. Electron வாங்கணும் உள்ள இருக்கிற inner electronsக்கும் incoming electronsக்கும் repulsion அதிகமா இருக்கும். அதனால வர electron gain பண்றதுக்கு hesitate பண்ணணும். Of course it will accept. But when compared to sulfur, electron gain enthalpy sulfur அதிகம் because size is going to be more. அப்ப ஈஸியா வர electron accommodate பண்ணிக்கும். ஈஸியா வர electron accommodate பண்ணிக்கும். இத நம்ம periodic property டிஸ்கஸ் பண்ணிருக்கோம். Third period elements के electron gain enthalpy always is very more when compared to second period elements. Please note this point. Third period element always has more electron gain enthalpy or more electron affinity. அப்பனா மீனிங் என்ன? எதுக்கு more negative value இருக்கும்? சல்ஃபருக்கு ஆக்ஸிஜனுக்கு more negative value. சல்ஃபருக்கு ஆக்ஸிஜனுக்கு sulfur has a more negative electron gain enthalpy when compared to oxygen. Sulfur has a more electron gain enthalpy when compared to oxygen. Oxygen के electron gain enthalpy in terms of negative is going to be in terms of magnitude is going to be less. Is going to be less. Why? Due to small size. Due to. Please note this. Clear? Get my point? Yes or no? Yes. Next last is third is going to be electronegativity. 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 Is the highest electronegativity? What is the order? Electronegativity order. Carbon. 2 nitrogen. 2.5. Next oxygen 3. 2.5 is 3. 3.5. 2 is going to be 4. Because is it clear? Yes or no? So after most Most electronegative element after fluorine is oxygen. Oxygen after fluorine, which one is the most electronegative element in the periodic table data? Oxygen. Is it clear? That's the more electronegative element. There you go. So this is after fluorine, oxygen has the highest electronegativity. Highest electronegativity. Down to the group, you know. Obviously, electronegativity decreases. There you go. Point here, you know. Down to the group, electronegativity value is going to be decreased. In the this is all concept is mixed of periodic properties as well as chemical bonding. If you are thorough in these two chapters, in the points of difficult ஆயிருக்காது புரியுதா அதுல தெளிவா படிச்சதுன்னா எனக்கு ஈஸியா இருக்கும். Next, the physical properties list. Physical properties. Physical properties. The first property is going to be very important point. So all these elements exhibit allotropy. All these elements exhibit, all group system elements exhibits allotropic form. எல்லா எலிமெண்ட்டுமே எக்ஸிபிட் பண்ணுவோம். Oxygen, sulfur, எல்லாமே allotropic formல exhibit ஆகும். Is it clear? So what is the allotropic form of oxygen? Oxygen allotropic form என்ன? Ozone. Allotropic form of oxygen is going to be ozone. Is it clear? Yes or no? Next to you. Next. Second point. Melting and boiling point. Melting and boiling point. Melting and boiling point increases with atomic number. Melting and boiling point increases with the increasing atomic number. But down the group, you know, melting point, melting and boiling point down the group increases. Will you go? Melting and boiling point down the group increases. Melting and boiling point down the group increases. But there is a catch. There is a catch. For example, in the case of sulfur and oxygen, okay, down the group, general down the group is going to be increases. We don't need to remember the data. Down the group, molecular mass, atomic mass increases. Melting and boiling point will increase. But down the group, increase. For example, the large difference melting and boiling points of oxygen is sulfur. The large difference between sulfur and oxygen. The large difference in melting and boiling point. Large difference in melting and boiling points of oxygen and sulfur. The difference is going to be more. The difference is going to be more between oxygen and sulfur. This is due to atomicity. This is due to atomicity. Is it clear? So oxygen may exist also. O2, your atomicity is going to be 2. Sulfur exists on polymeric form, means polyatomic exists on, your atomicity is going to be 8. Clear? Is it clear? So number of atoms increases now. Melting and boiling point is going to be increases. Is it clear? Large difference. Atomicity large difference. Is it clear? Next, anomalous behavior of oxygen. Anomalous behavior of oxygen. Anomalous behavior. Anomalous behavior of oxygen. Okay, so any reason anomalous behavior? First reason is going to be due to small size, high electron negativity. High, this is due to small size. This is due to first reason is small size,
small size, high electronegativity. Small size and high electronegativity.
Is it clear? Next. So your anomalous behavior first is when you compare H2O and H2S. H2O and H2S. Is it clear? So H2O, what is the physical state? Liquid. Liquid. This is going to be liquid. The liquid A because in a bonding. Hydrogen bond. In a bonding. Hydrogen bonding. Please note this point. Hydrogen bonding and liquid exists. Is it clear? Whereas H2S is going to be a gas. No hydrogen bonding. Please note this. Okay, H2O liquid because H2O hydrogen bonding. Is it clear? And each water molecule can form how many hydrogen bonds? Each water molecule 4. Each water molecule maximum how many hydrogen bonds form together? 4. Please note this. Each water molecule can form maximum 4 hydrogen bonds. Is it clear? Yes or no? Yes. So H2S is going to be gas, or H2O is going to be liquid. Second anomalous property. Absence of vacant d orbital. Absence of vacant d orbital. Okay. Is it clear? It limits its covalency to 4. It limits its covalency to 4. You know the theoretical of 4 exists. Is it clear? But if you see theoretical of maximum exists 4. But normal in practice like 2. Is it clear? Theoretically we can say hydrogen valencies can be 4 bond form. But practically it is 2. For example, H2O, oxygen 2. H2S, 2. Is it clear? So that is the point. Whereas other elements it can form more than 4 bonds because n orbital d orbital. Is it clear? Whereas other elements its covalency can go or it can extend beyond 4. Sulfur, selenium, covalency can go beyond 4. Is it clear? So that's all about the anomalous behavior. Next we are going to discuss about chemical properties. Okay, chemical properties. Chemical properties. The first thing we are going to discuss about oxidation state. Last year question. Oxidation state question. Okay. So since electronegativity of oxygen is going to be high, because of the value is 3.5. This is 3.5. So it shows only negative oxidation state. Oxygen source, important point, only negative oxidation state, that is minus 2. Negative oxidation state, that is minus 2. Except OF2 and O2F2. This is oxidation state, positive oxidation state. Please note this. O2F2. Always oxygen negative oxidation state except OF2. OF2 oxygen is going to be positive oxidation state. Why? Fluorine more electronegative. Fluorine more electronegative when compared to oxygen. Oxygen electronegative. OF2 oxygen electronegative. X. Fluorine always is going to be minus 1. Is this clear? It is going to be minus 2, 0. X is equal to plus 2. Oxygen is going to be plus 2. Similarly, in the case of O2F2, O2F2, always fluorine is going to be minus 1 oxidation state. Is this clear? So, 2x minus 2 is equal to 0, minus 2, x is equal to plus 2, x is equal to plus 1. So, in this case, oxygen is going to be plus 1 oxidation state. But oxygen is going to be a negative oxidation state. Why negative oxidation state? More electronegative. More electronegative. Please note this point. Is it clear? Second point. The stability of minus 2 oxidation state. The stability of minus 2 oxidation state decreases down the group. Decreases top to bottom or down the group. Stability of minus 2 oxidation state decreases down the group. Very important point. Next we go. Polonium hardly uses polonium, that is okay. Polonium never or remember minus 2 oxidation state level. Okay, is it clear? That's the point. So these are about the minus 2 oxidation state. Next, there are other oxidation states are possible. Okay, other oxidation states, other elements of the group. For example, if you are regarding oxygen, contain oxidation state minus 2. Okay, minus 2. Except in the case number 2 is going to be plus 1. Whereas we have other groups, other elements in the group is going to be, for example, sulfur, selenium, tellurium. This is the oxidation of other elements. Okay, other elements can show plus 2, plus 4 and plus 6. Please notice. Except other elements now, sulfur, selenium, tellurium. The other oxidation state means other elements in the group shows plus 2, plus 4 and plus 6. Is it clear? And tellurium, the more common among this. More common oxidation state is going to be plus 4 and plus 6. For other elements, the most common oxidation state is going to be plus 4. Is it clear? Next. Text we have sulfur, selenium, tellurium show plus 4 oxidation state with oxygen. And sulfur, selenium, tellurium show plus 6 oxidation state with fluorine. Sulfur, selenium, tellurium show plus 4 oxidation state with oxygen. Sulfur, selenium, tellurium shows plus 6 oxidation state with fluorine. Next, the last point. Bonding in plus 4 and plus 6 are mostly or primarily in nature covalent nature or ionic nature. Bonding in plus 4 and plus 6 oxidation state in nature covalent nature or ionic nature.
Covalent nature. In nature, covalent nature. In nature, covalent. Why covalent nature? Why covalent nature? Why covalent nature? What is the reason why covalent nature? Fajjon's rule. In a rule? In a rule? Fajjon's rule. Fajjon's rule padi. Cation having smaller size, high charge. என்ன character இருக்கும்? Covalent character. என்ன character இருக்கும்? என்ன character இருக்கும்? Cation having small size, high charge. என்ன character இருக்கும்? அப்போ higher oxidation state போக என்ன character அதிகமாகும் கேட்டா? என்ன character அதிகமாகும்? Covalent. Please do remember lower oxidation state, higher oxidation state. Higher oxidation state போக covalent nature increase ஆகும். என்ன nature increase ஆகும்? அப்ப lower oxidation state என்ன nature இருக்கும்? Ionic nature. என்ன nature இருக்கும்? Ionic nature. Is it clear? Please note this point. Is it clear? Yes. Okay, the last point we will start. Last point. Okay, you have NS2, NS2, NP4. How many oxidation states is possible? Applied by this configuration. Plus 6, plus 4, plus 6 and plus 4. Is it clear? Down the group, whether stability is plus 4. Down the group, plus 4. The stability down the group, plus 4 oxidation stability increases due to inert pair effect. Down the group, plus 4 oxidation stability increases due to inert pair effect. Inert pair effect. Down the group, stability of plus 4 oxidation state increases due to inert pair effect. Is it clear? This is a stop. This is a stop. Is it clear? So most important thing is oxidation.